Hi there, good morning. I always like coming to Bristol, it's very special to me. My middle name is Brunel, honestly, it is. My father was slightly obsessed to the point where my youngest daughter is called Imogen Kate Baguley, so her initials are IKB, just to keep him happy. I'm not kidding, it's true. So driving across Kittens Suspension Bridge last night was kind of cool. This is also the first time I've ever been on a badge. If you'll look at your badges, I'm there, and thank God I'm wearing different coloured jeans this year. I've never been on a badge before, so that's quite exciting. I came up here and ranted for 45 minutes last year, and I'm not going to do that this year. We decided to do something a little bit different. What I wanted to do, though, was just highlight to you a key area for me that I'm spending a lot of time, money, people, and effort on researching at the moment and investing development in, that I think is going to be really important for our industry over the coming years. And when it impacts you, might be this year, it might be in 4 or 5 years' time, but it's actually very important to us, and I think we're going to need to build for it now. Some of you may have seen last week or the week before, Michael Dell announcing the new IoT division at Dell Technologies called IQT. I'm going to talk a little bit more about that, because I'm going to say the words digital transformation once today, and that's it, okay? Not again, because I'm fed up with it, right? And I'm fed up with people putting up slides about, this is getting disrupted on all these other companies that have been disrupted. It's happening. Get over it. What's interesting to me, it is that there's some really sexy technology coming that I think is going to change the way that we run computer systems and the way that we architect computer systems, and that's important. Okay. So with these driverless trucks and 3M supply chain changes, et cetera, and innovation curve stuff. You'll hear these stats like, for example, the 787, we pull 500 gig, we're actually involved in it, we pull 500 gig of flight off that in terms of data, which then has to get chunked very quickly and decide what needs to be done next. 500 gig per flight, that's quite a lot, right? We work with some manufacturing companies where we're looking at 250 gig per day being pulled out of buildings, and one of them, they've got a series of very, very large chemical plant in Germany, that's not this picture, where they're pulling a petabyte per day per building out of their manufacturing environment of sensors and information that's going on. That's an incredible amount of data that's being pulled out that you have to sort through and do something with. And it's going to get worse or better depending on how you look at it. There's a couple of interesting side notes here. There's a technology now that we're working with one of the building companies on, which is using low energy Bluetooth. And it's really quite freaky. So what you can do is they've invented strain gauges. Those who did physics at school will remember strain gauges, which is a piece of metal that when you stretch it, the resistance changes, right? They've made these things so small that they cost pennies, and they have a little battery in them and something that scavenges energy off Wi-Fi and cell tower transmissions, which is not much, but it's enough that over a period of time, which could be weeks, it gets enough that it can wake up, transmit on Bluetooth to a local beacon going, my reading is 6, and then shut down again and gather again. And so what do you do with these? Well, you sprinkle thousands of them in the concrete mix when you're building a bridge. Thousands of them. And so by the time that bridge is built, the thing is continually talking to you, because there's at least one sensor waking up every minute or so, the thousands going 5, 6, whatever. Okay, you don't know where they are. So what's the point? But the point is you start trending them, and then when one of them always says 5, suddenly says 9, you're like, holy crap, something's up. And then you go and find out where that one is and drill in and find out what's going on next. That's the kind of stuff we're looking at here as people look at how they change what's going on. The data flows are getting interesting too. You've seen Amazon have a thing called Snowball. Have you seen Snowball? Which is basically if you haven't got enough bandwidth to upload from your data where you're coming from, so for example, oceanographic surveys, they go on a boat, they collect a load of data onto this box you get from Amazon, which is a small box. They do a massive one, which is a full-size truck, which is just full of disks. And then once you've finished, you ship it to them, and they then ingest it into Amazon, and you can then use it for calculations, etc. It's incredibly high latency, incredibly high bandwidth. Depending on how fast the truck is, it's over a terabyte a second on how fast the data's moving. It literally is. It's incredibly high bandwidth, but it's very high latency. So these technologies are coming, and what we're seeing is that, we just heard it here, right? If you fill in your passport, you're going to get a load of prizes for some stuff to put in your house. I've already got all that stuff. I've collected most of it over the years, Philips Hue, everything else. Now, the one thing I don't like doing is waiting. And those of you who've ever played with Alexa, and if you have Alexa, I pity you, because I do have it too. It kind of starts to take over your life, but then you decide you want to hook it into other things. And so you start hooking it into the Philips Hue lighting system. But the problem is, when I say, Alexa, turn off the bathroom light, or turn off the kitchen light, or whatever it is, which you can do, there's a delay, because what Alexa has to do is Alexa has to go and talk back to the Alexa servers. They have to then translate your voice into what it said. That then has to go to an API, which then talks across to the Philips Hue API, which then talks back down to the thing, blah, blah, blah. You get it eventually, and the light bulb goes, huh, like 4 seconds later, or 6 seconds later. I don't want to have to wait. And as we get, and I know that sounds bad, but trust me, because if that calculation is going on in my car to decide what happens next when a car pulls out in front of me, I don't want it to wait 6 seconds while it talks to the servers, right? I want my car to brake. And so what we're seeing is a rise in what's being known in the industry and called in the industry as edge computing. And so what's happening now is we had this pendulum, and we put it into Pat's keynote this year, this pendulum thing at VMworld, where centralized, decentralized, centralized, decentralized. We've centralized in cloud, and now we're seeing decentralization as stuff moves back out to the edge for calculation. So what we're looking at now is how do we take that modernized computer infrastructure, that data center infrastructure, and how do we expand and spread that out to the edge? Because ultimately what you're going to be doing is running minor, tiny SDDCs in everything. And I'm already working with a car manufacturer where we're putting a small version of what's called vCloud Foundation in the car. They're running vSAN in a car because it gives them the resilience they need across the nodes between. It's quite interesting. So as we look at what people are looking for going forward, there's the obvious ones. We want speed, we want agility, we want innovation, we want differentiation, and a certain level of pragmatism in how we go forward in selecting technology. These are the key topics that I end up talking to customers about. They want to talk to me about all of these things and how we're going to help them do it. And as we look at that and this coming edge, this world where we're going to have to start managing stuff at the edge, we have to think about how we modernize and build applications to do that. And so as we go forward, you'll hear a lot. I've just come back from DockerCon. Now, if you'd asked some people in 2014, VMware would have been dead by now and completely replaced by containers. Okay? Strangely hasn't happened and isn't going to, because containers aren't going to replace VMs, and PaaS isn't going to replace the next one. They're all going to exist together. Because what's going to happen is you have a choice of application architectures that are more suitable for different types of activity. So it forms up this kind of pyramid of ways of doing stuff in IT. So we've gone from the traditional monolithic 3-tier architectures. Go buy something from Oracle, run an application, job done, right? That's it. That's how you do stuff. To there's a massive choice of how you do everything now, and how do you build that stack out? So when we look at the choices you've got what we call provider native platform services here. These are incredibly fast to use, but they're very, very sticky because you sacrifice a lot of choices by using that fast service. A great example is Office 365. It's brilliant, right? It's incredibly fast to use. You go sign up, bang, you're done. But you're kind of locked into Office 365, but everyone is, so who cares? But when you're looking at that next service, that next software as a service at the top, how much are you willing to trade speed for stickiness? I hate to use the word lock-in, because it isn't really lock-in, but it's that stickiness to how you build and architect things. But they have their place, entirely have their place, and will be part of what you do going forward. In fact, 50% of when we talk to customers of what they call using public cloud sits up here in things like Office 365 and Salesforce, et cetera. The next one down is sort of public or private PaaS or CaaS. CaaS is containers as a service. Okay, so it's one down from PaaS. I'm not quite ready for a full opinionated proprietary PaaS. I want to go one down to a CaaS. Examples of PaaS are things like Cloud Foundry, which is the open source version from Pivotal, and then you've got other ones like Lambda and Microsoft Azure, et cetera, where you're turning up with just some code, like some Java, on this platform, and it does all the execution for you. You want a little bit more control? Take your Java app or whatever it is and run it in a container to get a little bit more control as to what goes on with that and a little bit more through the hooks of what's going on and how that application is architected. So it's how much within that layer you're willing to give up. So what you get there is applicational agility. So wow, I can move things really fast, I can very quickly move around, I can do a little bit of customization. But what you have is a possibility of operational drift. And what is operational drift, Joe? I've never heard of that before. Operational drift is the fact that you're going to have to start implementing different operations models and techniques and tool sets for the different strata in this stack. And that's a problem for some of our customers because they've built all of their operational consistency down here. They know how to do VMs. They know how to do bare metal. And suddenly, someone's saying, oh, we're going to do containers now. Well, that's all well and good, but how do you do backup in containers? How do you do storage in containers? How do you do consistency? All these other different things that actually what we call day two. And that's really what we're focused on at VMware is how do we give you day two operational consistency across the whole stack? And so the idea is that you're going to be running either public or private IaaS for a very long time. And then on top of that, you might layer containers as a service or PaaS for application agility as you go up. I'm just trying to click here, there we go. And so the VMware vision really is about providing that base down here to allow you to do that in any cloud. And that's what we've been focusing on, and that's really where we've been talking so much about this year, and those announcements we've made in that space is one of the reasons why our stock's the highest it's ever been, is because people realize that we're providing this solid base for everyone to do pretty much anything they want to do. You can choose to run in private clouds or public clouds. You can choose to run either traditional cloud-native or SaaS apps, and you can deliver them to any device, be that a mobile phone, a watch, or a car, or a wind turbine. That's what that is. People always ask me, what's that one? That's a wind turbine. I don't know. That's a Nest thermostat. I don't know what to do with them, but there you go. So, graphics people. I don't do this slide. But what we're doing here is literally saying, okay, fine, we're going to give you that choice. Give you the choice when you build that architecture to build that strata up. Why would you use all of them? Well, let me give you an example. You might have some sensors out there on the edge collecting data on a thing. Those sensors might be pointing towards what's called functions as a service. Now, functions as a service is where literally you have event-driven function execution. So rather than having a VM sat there all the time waiting for that sensor to wake up and say hello, when the sensor does wake up and say hello, we just spin up something just to run and deal with that sensor and then kill it again. That's what functions as a service is. That's what you'll see in Lambda and other things as well. So you might have functions as a service. That might be running in the public cloud. That might be then talking down to something you've built on platform as a service, maybe Cloud Foundry. There's an app you've built there. That, in turn, might be talking down to some stuff you've built in some containers, which does the middle layer, maybe the middleware piece, maybe actually does the web serving rather than the application intelligence. That then talks down to your systems of record, which are running in some SQL servers on some IaaS in some VMs, which in turn talks back to the database. Now, the fun thing about this is that people think that everything's going to happen this new sexy fast way, but they don't quite realize that actually something comes down to something maintaining state somewhere, some point. And one of the things I would encourage you to ask when people get all excited about microservices and new style architectures is to ask them, okay, where are you maintaining state? Because most of them don't have an answer to that. If you go and use Amazon's website or any website, what you'll notice is it's really fast, right? When you're browsing, you're looking stuff up, bang, 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 suggest this, have you bought this, do, I can put stuff in the basket. It's so fast. Have you noticed when you click to check out, things slow down? That's because up until that point, you've been in a, we don't care if this bit fails, I'll spin another one up. You know, searching for something and that node fails and microservices, I'll spin another one up it comes, who cares? But the minute you start going to checking out, where it gets to finance, transactional records, and essentially dealing with money, we have to go to a single-threaded architecture almost, where it sits down and slows down, and that's where you'll start to see this. And so in your architectures, you're going to have that too, and it's stratifying that. And what you're seeing in our industry is people come up with more and more best practices on how to do each bit and layer of that chain, rather than it all sitting in one monolithic server. In the old days, we used to get that Oracle application and try and shard on the back end to make it a bit quicker. Now we're changing the entire application architecture on top. And it's disrupting things like Web3 and WebLogic as they start to get spun out into containers. But the underlying piece will always be that stack. A couple of things here. Edge computing sits there, obviously. Telco networks. The telcos have suddenly realized that virtualization is a cool thing, something everyone else in this room realized 15 years ago, but they've now realized it. So they're now running out and virtualizing all of their physical infrastructure. So stuff previously, if you went to a telco radio control node, which sits at the bottom of a cell tower, there'll be a 22 or 42U rack or multiples there full of very proprietary kit from a bunch of people that sell network hardware. What that's now being is that's swapped for x86 servers. And they're running all those previous functions as VMs, which is called NFV, or network function virtualization. And so the telco networks are being rapidly transformed. I get accused, and there's going to be a presentation a bit later on with Josh on NSX. Someone said to me, why are you bundling NSX into everything you do? We announced a new thing called App Defense where it needs NSX. We're not. what we're doing is, as NSX, we roll NSX out, we realize that NSX enables us to do all these new sexy and amazing things that we didn't do before. So it's not a case of let's find a way to use it. It's, oh, I didn't think we could do that. You know, NSX is what allows us to do encrypted communications right out to the endpoint. NSX is what allows us to run the telco networks. NSX is what allows us to do app defense. It allows us to do these new levels of innovation. So if anything, the most important thing for us over the next few years, and I think for you guys too, is going to be NSX. That network virtualization layer that sits on top of any other network layer you're talking about, by the way, so it's not competing with things like ACI, it's sitting on top of, is becoming fundamental of that operating system of the data center that I talked about last year. So we're focused on giving you this globally consistent infrastructure as code. And globally consistent is the important bit. Remember I talked about operational drift? I want to make sure that the telemetry and the developer experience is the same no matter whether you're doing this in a private cloud or data center, in the public cloud, or branch or edge compute. Another really good example of branch or edge compute. Remember I told you those telcos are now going to fill those racks with x86? Well, that's a massive over-the-top technology opportunity for those telcos. Because now if I'm a telco, I can turn around to a betting company and say, hi, we're the telco that happens to run the cell towers next to Old Trafford, and Manchester United are playing at home next week. Would you like to move all your front-end web servers to be in the cell tower for your betting app? So you can be the fastest. And you go, oh, wow, that's really cool, yes. So for 4 hours, you go and spin them up, maybe in some containers or in some VMs, because they've extended their SDDC out to that point. You can literally drag them out, spin them up, kill them at the end of that 4 hours. Unthinkable today, right? But how cool would that be? And think about for your business, maybe how being able to push some of that compute close to the edge, close to your customers for a short period of time might change the way you do things. So we look at this globally consistent infrastructure as code to support all these functional ways of delivering stuff, whether it's IaaS, whether it's CAS, PaaS, or FaaS, those ways that people are going to talk and build those applications. So the hybrid cloud platform we've built is 2 parts. We look down here at compute, storage, and networking and automating the lifecycle management of those to make them one automated lump. We do that with a piece of technology called SDDC Manager, which sits as part of VMware Cloud Foundation. VMware Cloud Foundation is a bundling of NSX, vSAN, and vSphere into a managed build, i.e. bought as one piece of hardware from someone like Dell integrated, or you can go onto an HCL and build it yourself out of vSAN ready nodes, etc. Or you can go and buy someone who's already building and operating VMware Cloud Foundation for you, like Island. And that's where this piece comes over here, where we have all of our VMware Cloud provider partners, of which there's now 4,500, all running that same globally consistent infrastructure. So it doesn't matter where you choose to move your VM, you'll get the same experience. Be that Amazon, be that OVH, IBM, or someone more local like Ireland, it allows you to do that. The same up here, VRealize Suite. I didn't come up with a name. VRealize Suite allows you to do that management across all of those clouds, that one consumption portal with the automation behind how you deploy all that, to give you that consistent, simple, secure cloud platform to then deliver to people that are building stuff for you. So when you're looking at modernizing IT, we're trying to help you in making the cloud easy. Choosing which cloud you use shouldn't be, am I going to get locked in? Am I making an architectural decision here that I'm going to regret next year or the year after? It should be, is this the best place for me to do this part of my application? Yes, fine, go. That's what we want to enable. We want to simplify the developer consumption. Do they want to use VMs? Do they want to use containers? Do they want to consume a PaaS? Do they want to consume containers as a service with someone like Kubernetes? Yes, we can do all that. We can do it on-premises, and we can do it off-premises in public cloud. Your choice. Globally consistent operations across those. And so again, it's looking for that consistent operations model. Because I can tell you right now, you're not going to get more admins in future. You're going to get less. But you're going to get more to do. So the more you can do now around coming up with consistent operations models that are focused on TAID2, the better. I was at a presentation recently where someone talked about how they were transforming their business by containers. And they said, oh yes, we've worked out we can save 66% of our IT costs by using containers. And he then went on to explain what they'd done. They'd got one Java app which did a lookup against one table in a SQL database, and they'd put it into a container, which is quite easy, really, to be honest. You can write a script to do that. He did that, and then from that extrapolated across his entire IT estate the savings that he could make, and hadn't done any of the rest, but that's what he thought he could do. But then we went and quizzed him, actually, and it wasn't me, it was a presentation, he was quizzed at the end. We said, so you moved this Java thing off a VM where it was running in JVM and you moved it up into a container. What did you gain from that? Better consolidation ratios. Well, you could have done that in a VM, so next question. What are the problems you have? Well, we haven't quite worked out how to monitor it yet, or back it up. What was it? Yeah, we're having storage issues and mapping the storage. You're like, okay, this is great. This sounds really good. So consistent operations is very important. So we're trying to make sure that if you want to use containers, we'll provide you with a consistent operations model for using those containers. So putting that all together, what we're giving you here, if my clicker works, is down here this infrastructure as code that goes across multiple clouds and supports multiple application frameworks. That's your VRA plus the software-defined data center, or vCloud Foundation, right? That's the IaaS layer. It truly does go across clouds. That's the big thing for this year that finally people realized. I did actually talk about it a lot last year, but this year the press and the Wall Street people worked it out, that typically now you've got the point where you can run these VMs anywhere, including in Amazon, and pull them back out again as well. So again, you're not making architectural decisions that you might regret. On top of that, providing the automation tool set, so that consistent operations across that. So you can manage the SDDC, manage applications across clouds, and accelerate the application of these apps and infrastructure, because you're going to get involved in the future with something called CI and CD, which is continuous integration and continuous delivery. As you start to move faster in delivering applications, you're going to have that operational consistency to update them faster. And then operations with VROps gives you that sort of closed-loop optimization. You get these real-time application analytics and allows you to see across those. There's some really cool technology called VRNI, which you'll maybe see later on, which gives you some phenomenal visual information about how your application infrastructure talks to each other. And that's on-premises, off-premises, doesn't matter where it is. So really, what we're looking at VMware isn't how to rule the world, but how to give our customers a globally consistent experience. And that consistency from the cloud all the way to the edge. And I've got a project I'm running internally right now, which is how do I deliver to you a fully supported 2 and a bit node box. 2 and a bit is for the witness for vSAN, that is solid state, quite cheap, but runs the full SDDC stack. NSX extends out to it, it's got vSAN on it, it runs vSphere, so you can freely, for your branches, go and put one in every branch. We're talking to a retailer that has 4,000 branches, and you go across those branches, and every branch you go in, there's like the manager's office, and in the manager's office, there's like a desktop machine, and there's a 22U rack with sort of a weird piece of WAN equipment, and then some switch from 1904, and then 2 bits of servers and something else. We've all been there, right? And I'm going, what if I could give you one box? One box that did the SD-WAN bit, that also provided you with the ability to run a load of VMs that you could do for running a EPOS system for your tills. At the same time, we could do it for running 4 VDI desktops for managers and other people to do that. And it's all secure and backed up, etc. And it's so dumb that you can get it what we call FedEx managed, i.e., if it breaks, a guy turns up and plugs another one in. That's what I'm working on right now. So when I talk about consistency cloud to edge, that's taking SDDC technology that we've built and scaling it down and out. It's really exciting for me anyway, because I'm a complete geek. So that then allows you as businesses to focus on differentiation, on focusing on doing what you're doing, not focusing on what's going on in the manager's office. And at the same time, it allows you to go and meet developers all the way, not halfway. So when the developer comes and says, I want to play with Docker, you go, yeah, there's the Docker API. We've installed Vic, it works. Oh, I want to put something in production. Oh, PKS gives you Kubernetes. You can do that too. Oh, you want to play with OpenStack? Fun. Right, well, there's VIO. All that stuff there is making sure that developers have this consistent experience, no matter where they want to do stuff, how they want to do it. You want to do it on Amazon? No problem. So I suppose I could go, I mean, if I was given 3 hours, I could do a much more detailed presentation, but I was given 20 minutes, and then we got questions, so I'm trying to pack it in here. My main point to you is all of this stuff is coming. For your companies, even if today you've got 10 servers that you run 15 VMs on, right? I promise you the world is going to change. You're going to change the way that you build applications, you're going to change the way that you consume applications, you're going to change the way that you build solutions for the business that you work for and for your customers. And you need to build the foundations today, the operational foundations today, to make it easy to expand into those new areas. So out of today, if I could encourage you to get one thing, is to look around these people and work out who's going to give you that operational consistency from the data center to the edge, out to your end user devices, out to what's going on in the branches or wherever it is, or the cars that you use, or the trucks or the vans that you ship around, or whatever it is you do for a business. and make it as easy as possible for you to operate across all of that and not have 57 tools. Because I'll tell you right now, there is no single pane of glass, right? That is a complete made-up piece of marketing. You're never going to get a single pane of glass. You can get a lot less pane of glass than you've got right now, and that's what we're aiming for. So with that, I think we're going to do some questions and answers. We've had questions sent in from the audience in advance. I've not seen all of these. I've seen a couple of them, so I'm a bit scared about what's going to come up.
So yeah, what we wanted to do is make sure that everyone had an opportunity, that if you were alone with this man for 10 minutes and had a few questions to ask him, what would you really ask him?
I don't even want to be alone with myself for 10 minutes.
And we filtered through those questions to pick some of the best ones out. So Andrew Weldon racked his brains and came up with the best question he could ask you.
Yeah.
He wants to know, how do you like your eggs in the morning?
That's the best question he could come up with.
I don't know if Andrew's here.
Poached is the simple answer to that.
Nice.
Mainly because I spent my formative years in the army where everything was fried, so poached was a treat. So if I could get poached, it's always been that. Even downstairs, you can't get them.
So there's a bit of a segue from eggs. So Mark Chapman, who is a VMUG member as well as I think he's somewhere in the back there. I think I did see him anyway.
He's going to hide now.
So I'm going to ask the question, then you may have to explain the question slightly to everyone in the audience.
Okay.
So the question is, how can I make chickens when my legacy apps need SQL?
How can you make chickens when your legacy apps need SQL? So this goes to a story. I used to tell a story, if you go on YouTube, you'll find it, about things called chickens and kittens. The funny thing is that's believable, having seen me present, right? And the concept of chickens and kittens is the fact that, you remember I talked about these different strata, about the VMs, and then you go up. And very quickly, I'll do chickens and kittens in 30 seconds. It's a different way of managing infrastructure. So if I go and ask a particular IT infrastructure person about their servers, they'll tell you, they can probably tell you the names of all their servers, they can tell you the IP addresses of all their servers, they can tell you when they were patched and all this kind of stuff. That's because they're managing them like little fluffy kittens, right? Like pets, you'd look after them. Every little one has its own little name. When you get higher up the stack into microservices, you're much more managing them like chickens. When I've got 4,000 chickens, I don't know any of them. And the difference between managing a kitten and a chicken is a kitten, if a kitten's sick, you take it to the vet. I know, I've got cats, and it's really expensive. If a chicken is sick, it goes for a one-way trip around the back of the chicken shed, right? And you get a new chicken. And that's the fundamental difference between microservices and that sort of container-based architecture and PaaS to the traditional IaaS. So the question was, how do you do chickens with SQL servers?
Yeah, with
and I think I kind of
more traditional applications, not just SQL servers, sort of.
So traditional applications. So I think I kind of answered that in a way. So there's two different things coming out here. One is you choose an interface point where you trip over back into that sort of monolithic point. So you can have a chicken-like front end. This sounds really weird now. You can have this sort of scalable, I don't care front end, which typically you use for sort of web balancers, load scaling, all that kind of, load scaling, et cetera, up front end. And then, like I talked about with Amazon, when you tip over to that point where you get transactional, that's when you maybe switch into having your SQL servers today, or systems of record, or whatever we call it. But there's new types of application constructs that are coming out, things like Cassandra, et cetera, that are popping up there that are more sort of evolving SQL. When I was at Quest Software, must be over 10 years ago, we all got excited about NoSQL, because someone had suddenly broken Brewer's Law. Well, we found out we haven't. But there's new and interesting ways of doing that. So I think it answers, again, you're not going to take your whole application today and suddenly turn it into being chicken-based. What you're going to do is you're going to stratify it and say, okay, this bit still needs to be a little bit sort of pet-like, kitten-like. These bits are going to be chicken-like, and so on as we go forward. And you'll get up here the benefits of scale, speed, and reliability, and then you'll have to work a bit harder on the back-end piece. But the nice thing is it gives you a chance, if you can do the front-end stuff, to make it look good really quick and give you more time to sort out the hard stuff.
Thanks for answering. Everyone likes to hear about the chicken and cat story. I think it's a very good way of describing it. So from my perspective, obviously, Computer World primarily deal with small to medium-sized businesses. Mm-hmm. VMware has been very inclusive over the years, especially with its Essentials product line, that effectively, no matter what size you are, there's a VMware product to suit you and to help your business kind of move forward. We've heard today things about containers, NSX, telco networks. What is VMware doing to ensure that the small to medium business can still be part of that VMware vision directly and not just serviced by a VMware provider, maybe?
It's like you set these questions up, but he really didn't. There's a couple of things there. Obviously, we're looking at how we bundle and license our products, which is something I have nothing to do. So I know nothing about bundling or licensing. I learned a long time ago working for software companies. If I even think about learning about how much our stuff costs or how it's bundled, I just get into trouble with people that wear ties who are called salespeople. So I don't bother. So, and how we're delivering stuff is changing. So we announced this year launching what we call cloud services. So a small business might look at something like VRealize and the blueprints and go, that looks amazing, I'd love to have access to that, but then go and look at how much it costs and how many VMs they're going to have to build to implement it and go, holy crap, I can't do that. We're now offering those products as a service. So you'll see next year the VRealize automation, the products like that will become available as a service to consume on the internet. The same as we're doing already with a lot of the things, such as already today as a service, you can consume things like App Defense, which is the security tool. So I think by turning them into a SaaS model where you pay for what you use, you don't have to build the infrastructure to use them, I think that's making them more accessible. And we've always talked about, how do you make it easier for the on-premises piece to do that? Well, remember I talked a bit earlier on about converged infrastructure to an extent, where you've got VMware Cloud Foundation. So ultimately, as a small business, it could get to the point where you come to someone like ComputerWorld. ComputerWorld gives you a converged infrastructure box that they manage and run on site for you. You do all the VM stuff, and then you're using as a service to get to all the stuff you need, but you're taking less and less of the day-to-day boring pain out of things like managing that stuff. So that's what we're doing, trying to simplify it.
And things like AirWatch are a fantastic example of that kind of service methodology and the way they kind of launched smaller bundles and things like that. So
an App Defense is only available online as a service. You can't actually install it locally. If you want to use App Defense, you have to use the cloud service.
So I think you've largely answered this question, but maybe just a one-word answer or a short sentence. John Ward asks, with statements from the past, such as the year of VDI, everything's going to the cloud, do you think containers is next, perhaps, overhyped new tech? I think I
already answered that one. The year of VDI is a running joke amongst myself and a few other people in the industry, because it's always been the year of VDI. I've heard so many people, it's the year of VDI, and it never really is. The same with, what else you called it? You talked to your VDI and you talked about, cloud takes over the world. Yes, brilliant. Yeah, by 2015, apparently, everything was going to be in the cloud. And no one in this room would have a job, by the way, so congratulations. Containers, as I said, it's not either or. It's another option for a way that you can build a layer or a strata within an organization. It's not necessarily the answer for everything.
I think a segue then.
And they run in VMs anyway.
There's lots of talk about containers.
Yeah.
I don't have a development team. Should I be caring about containers? Is it
Not
ever
really,
likely to come?
No. So this is the other thing. We live in this sort of rarefied world where we seem to think that everyone has developers and everyone cares about developers, whereas 99% of this room have no developers, don't care about developers. They buy stuff off the shelf, right? And you run it. So you'll only start caring about containers when ISVs start shipping things in containers, which I think will happen because it's a much easier management paradigm to some extent than it is necessarily managing a VM image and so on and so forth. Pushing out a tar file as opposed to pushing out a VMDK ISO image is going to be a bit easier. So I think you'll see containers come, but by that time you won't bother because it will be something that's built into what you're operating. So you won't have to worry about the fact it's in a container or not. It's just something that you do and run. So it'll be like, when someone sends you a Word file and you haven't got Word installed, you'll install Word, you can open the Word files. On your infrastructure, it'll be, someone wants to do their application in containers, we'll just click and install the container layer, and then you can be able to do that. So that's exactly what we're building towards.
So there's two questions. I'm kind of going to blend them because I think you may have touched around some of it. If we look past the cloud, however many years away you wish to look into the future, what's next? And the other question that probably segues into somewhere about it is, what are VMware doing to really capitalize the use of artificial intelligence?
Well, AI ties into what's past the cloud. So I often get asked the question, who's going to win the cloud wars, right? Who's going to be the winning cloud? Is it going to be Google? Is it going to be Amazon? Is it going to be Microsoft? Is it whoever? The answer actually, to be fair, I think, and from the conversation I have, there's a whole section if you go on our website in the research business in Octo, where we're looking at AI and machine learning, which are different things, by the way. And if you don't know they're different things, go and find out why they're different. I truly believe that the winning cloud platform will be the one that has the easiest to consume and best AI platform. So in 5 years' time, the most popular cloud will be the one that has the easiest to consume and best AI platform for you to push data into or to leverage. And so also there's a thing to do with data sets as well. So people like Google, Amazon, Facebook, et cetera, have massive data sets in which to build amazing AI. So that also is going to help. So, what comes after cloud? What comes after cloud is truly applying AI to collected data sets and then pushing that out to the edge. And the pushing it out to the edge is where we sort of come in with the edge technology I'm talking about, because I talked about all that stuff being executed locally. That 1 petabyte of data out of that building, what we're doing is we're putting edge devices in there which will run intelligent AI engines which will work out how much of that petabyte actually they need, more importantly, work out what the intelligent heuristic results are of those sensor sets and just send that back. So the intelligence is not, we take it all in the middle and crunch it. It's going to be we crunch it at the edge and send back, what comes out from that. So that's kind of what we're working on there. And then there's the inverse of that. If you look at, say, self-driving cars, the way that Tesla drive PX2 units in their cars is that they perform AI at the edge, which is executing on a machine learning algorithm, which is built in the middle. So what happens is the cars are collecting information all the time, and if you park your car up, you'll see overnight it uploads a load of data on your Wi-Fi network. That's put into a machine learning engine back here, which actually crunches and works out a better AI engine for driving, that then pushes back out a new model to the car on like a weekly or monthly update. So the car itself isn't working out how to drive. It's executing on a model and collecting information to be sent to the center to then, it's kind of more like the Borg than anything else, really, to be fair.
Is infrastructure as a service just a box-ticking exercise? As in, yes, we're in the cloud now, where actually we should be concentrating on PaaS and SaaS being the true destination to the cloud?
So I talked about all layers being important. The PaaS and the CAS are going to be built on IaaS. So, IaaS is important. I don't think the fun thing is I think a lot of people thought people were going to build a lot of on-premises IaaS because they suddenly thought everyone was going to have like an IaaS where all the departments are consuming and you're billing internally. I don't think that's ever really going to happen, even for our largest customers. They're not really building an on-premises consumable IaaS. What they're taking is the best practice about running infrastructure at scale and using that to build a better operating cloud on-premises that's not necessarily infrastructure as a service, that they can then build these other layers on top of. So I think IaaS or infrastructure as a service is important, but it's much more of an operational methodology than it is something to do with technology. It's the understanding of how we operate our VMs and taking stuff out of paper and automating it. So that's where things like VRA come more important, because people should be automating more than they are. And I've been banging on about automation at VMUG now for 6 years, that's what people should be focusing on. So IaaS is more about automation than it is about any particular building an IaaS kind of thing. So yeah, people should focus on that, but focus on automation.
Automation is really key, and I mean, no matter which way you look at it, if you're doing something time and time again, why are you doing it time and time again? Why haven't you automated yet? And you can look at that all the way from a help desk ticket and something you're doing time and time again to infrastructure rollouts and everything really.
The number of companies I go to that still have a sort of paper approval-based process for spinning up a VM just scares me. Why do you have that there? Because it should be automated. You should be able to go click, spin up the VM. And if someone comes, why have you spun that VM? You should be able to kill it again. It should be that simple. But I think people have taken, I can't believe we're still saying this in 2017, but people have taken physical operation models and tried to apply them to virtualization. And you can't do that. It's a whole different way of doing things. And that was brought home to me recently. I was having a conversation, as you do, with the head of Italian air traffic control, which is a kind of weird thing, about drones. And the challenge that most people are having is that there is a very well-established air traffic control methodology for planes that people are trying to apply to drones. And that's where they're going wrong. So the Italian Air Traffic Control Authority with some others are coming up with a new way of doing air traffic control, understanding that drones are different to planes. By going look at my customers, and they're still trying to do plane-based air traffic control for VMs, if you know what I mean, when actually they're more like drones, if that makes sense.
It's kind of, as I said in my statement about strategy and vision, it's being willing to change, being kind of looking at what you're doing and kind of being open to that change, not just accepting, well, we've got to do it like this way, but what can this new technology do for me?
Totally.
I mean, I've had one customer that had a change control, paper-based change control process about snapshotting a VM.
Oh, I've got one that does it for vMotion.
Nice.
Yeah.
I have seen that.
You have to get an approval to vMotion a machine off another bloke.
And DRS needs to be set to manual.
Yeah. Brilliant.
But we want Enterprise Plus still. What is the likely next big innovation for end-user computing? I never know how to feel that ask you end-user computing questions. I don't know. How do you feel about end-user computing? What is the vision? Obviously, you said about never
It's funny
year
because
of
I get
VDI.
asked a lot to talk about not end-user computing, but half my speeches are end-user computing and talk about what we do in end-user computing. And I touched a little bit on that last year here.
Start with the user.
Yeah, start with the user was what I was banging on about and I still am. And I think we're getting to the point now in end-user computing where people are realizing that it's not about managing things, it's about managing people and data. So I feel I'm having some success there. The next big thing in end-user computing, it's a difficult one to answer. I'm not sure I actually, know off the top of my head. I know what we're working on and looking at in some sort of secret corners, but I think it's actually understanding that there is no such thing as an end user device. There's an end user. And what you're delivering to is that end user, not that person. So it's getting that consistent experience for that person, no matter where they are, is probably going to be the next big thing. And everyone promises it, and we're starting to get there where we can do that. But actually being able to deliver that consistency experience wherever you are is going to be it. Device-wise, there's a whole manner of exciting stuff going on with devices. But I think it's interesting. I'm waiting to see what the next big innovation is in mobile devices. Because if you look at what's going on, I mean, the difference between the iPhone 8 and the iPhone X and the iPhone 7 is marginal, right? It's got a face recognition. There's nothing like, wow, that's going to change the world. So I think we're overdue some kind of end-user device, wow, that's going to change the world thing. You saw the VR stuff outside. There's an awful lot of cool stuff coming in with augmented reality. We're doing a lot of playing with augmented reality at the moment. Some of the micro HoloLens stuff, the Microsoft HoloLens is really quite cool. And we're working with, there's a really cool video actually, if you look online, nothing to do with us, to do with Microsoft, where they've got surgeons who can, obviously if you're scrubbed up, you want to stay clean, but their surgeons can just turn around wearing HoloLens and manipulate using their hands full 3D MRI scans and then turn around and sort of put it into the patient to see, in virtual reality where the thing is. And that's cool as far as I'm concerned. And I've actually got a friend who's a radiologist. And I remember going to dinner with him about 5 years ago now. And he disappeared during the dinner. His pager went off, and then he came back like 45 minutes later. And I said, where have you been? And we all sat around eating dinner, and he said, oh, I've been off to do some work. And he told me what he did. In his shed, in his garden, he did live radiology diagnosis, manipulating machines and God knows what else, remotely to a soldier in Afghanistan in Camp Bastion. And so they were getting access to his intelligence through a VR headset, an early one that they were playing with there, because that's what they were playing with to make sure that, if you end up in Camp Bastion, you got the same level of care as you would have done in Great Ormond Street or Harley Street or whatever it was, because they were finding ways with technology of getting those guys to the far end. So end-user computing is going to be about connecting people better and connecting people faster, I think.
Well, thank you very much, Joe. Cool. Thank you for sharing your opinion and answering a few Q&As from the audience.
Be around. Cheers. Thank you.